More proofs!
What else can I prove?
What else would you expect out of math?
I don't know, maybe not proving stuff?
Why would we not prove things?
Because
Then you just leave it unproven.
Yeah. We might not prove something because we've already proved it before because we're doing too many proofs.
Gross. My teacher friend had a worse start to his Friday than me.
What happened?
I texted him and I was like, nothing like making a kid cry to start your Friday. Like, it's like as a joke, right? Like I feel bad, like, but I'm trying to hold kids accountable for their work. So he texted back like, man, I'll take that over a kindergarten toilet that's clogged and still kept being used. Was full. He had to plunge it, then mop.
Wait, why did she
And
have to?
he was probably the only one that would. The other teachers were probably like, I can't do it. I'll get sick. I can't. And he would just be like, it needs done. Yeah, Dave. These are the Dave I talk about.
Oh, you talk about people. I don't think you.
Dave and Randy. They're the main people I talk about. Dave and Randy. They're like my only friends. And like my wife. So, you know.
Mr. Hudson, you
What?
sound like an. Are they both math teachers?
I choose to be cast where I am, thank you.
Are they both math teachers?
No, Chelsea works for the state. She's the health department.
I've never met you. Should have got Chelsea to fix the toilet. She's in the health
The
department.
weird thing about when you have kids, seems like you have less adult interaction. So, unlike yesterday where we avoided congruent triangles, today we're going to dig into what can congruent triangles actually tell us. So, our task is for each of our statements below, we are going to try to organize an argument, probably 2-column, if I were to guess based on our past with each other, to prove whatever we're asked to prove, right? So, first thing we're going to do is prove that the diagonals of a rhombus bisect the angles. That is specifically, prove ABD is congruent to CBD. So,
Hey, wait for it. Don't hug her.
excuse me, this is one of those, it doesn't matter if we know it, how do we prove it? This is what we're looking to prove. ABDCB, oh sorry, this one.
But I don't think that's right.
Yeah, no it is, because that would be bisected. That's what it's asking us, that they bisect the angles.
Diagonal bisect angle A.
So I want you guys as a group to decide what we will all write down as step 1, statement reason, then step 2, statement reason, step 3, statement reason.
So we know the side is equal because it's the reflexive property. Oh, DD.
Is that what we would start with?
DD.
Thank you, Athena. We start with the given.
I thought we already knew that we. Oh, the given.
Are we allowed to just say we already know this?
Oh, and you talked about it so
No, we have to write it down. We're going to write this. What's the temperature in here? Or are you just using the laser?
Check it on. Make sure they don't have the Wuhan coronavirus.
Actually, that's legitimate.
Wait, tell me what's happening. What is the?
I heard the Wuhan ain't nothing to mess with.
I'm very.
Yeah, we were talking about that in.
So, step 1. Well, hey. Wuhan is not in this classroom. It does not matter. The reason might be given. What's the statement? What's the statement that goes with given?
A, B, C, D,
So write it down. SR, make your 2 columns. ABCD is a rhombus. Sorry, quickly, I'm going to cut this out so I can write below it. Yes, I had one of those too when I used to make t-shirts. Because when you screen press t-shirts, you have to get the ink to a certain temperature so that it actually cures in the fabric. Otherwise, it'll just wash out. So if you get a shirt like this is a screen press shirt, the ink is just melted into the fabric. So when it starts to wear away and disappear, that's why. It's just melted in there. Sorry, I got to teach you guys about more than just math, right? So you guys said the given is it's a rhombus. Where do we go from there?
We know that the diagonal bisects.
DB is equal to itself. Reflexive property.
But it's a given. We have to do the givens, David.
Yeah, I have a question.
The angle P.
Why did you bring up that ABC is a rhombus?
Never mind.
So wait, so if we're saying, because then we can use da-da-da, like, shouldn't we just use that right now? Like, if we've said it's a rhombus, let's say something about a rhombus. So this would probably be definition of rhombus, but what do we want to say?
The lines are parallel? Like AB is parallel to DC?
Okay, so write it down. AB parallel to DC. Do you want to write the other one too?
Yeah.
AD parallel to BC. All of you should have line markings above them if we're being accurate here.
Well, then we can say that DB.
Then we could do the reflexive property in the bi.
So wait, AB, all of them are congruent?
No, they're all the pairs are congruent to each other. AB and DC are congruent. And
Wait, then what quadrilateral has all sides congruent to each other? Well, yeah, but
not all sides, but like the pairs.
The rhombus has all sides. We did.
Oh yeah.
this is why.
Okay.
So that's why we did it. It's all good to forget that, but when I pause, like think deeply about like why won't he write down what I said? Like AB congruent to BC, congruent to CD, congruent to DA. All of that is definition of a rhombus. Did you say double tap?
Oh, because it's the same thing. Oh, I thought
That.
Yeah, I was.
What?
the bottom, like, because it's the same thing, definition of a rhombus, so you could just write.
Oh, all of that can just be the same statement. So this would be statement 2, reason 2. And look, you just take up like a lot of space over here. So then 3, you guys have said this multiple times, and I don't disagree with this, but we just had other stuff to do first. DB congruent to itself, right? So DB congruent to BD. Reflexive.
Could we just write reflexive or should we write
So we know that DB.
Prop. We always abbreviate.
Okay, so then
I
we
know,
can
but
say angle angle A. Oh, can we just say angle? Oh no. Angle ADB is
So, yeah.
congruent.
Okay, well, so since it's an isosceles triangle, so it's split into isosceles triangle, so you know that.
Wait. Have we said that yet?
No, but we can
Let's say that.
so then we can use it.
So, ABD, CBD, or whatever you want to say, triangle ABD, and triangle CBD are isosceles. By definition of isosceles.
Oh, two.
Yeah, because they have 2 congruent sides. We have shown those sides congruent to each other.
Well, okay, so since they're congruent, since they're isosceles, we know that like
They're
CBA
congruent triangles.
and CBA. Should we CBD and CBD are equal? Can you scroll up so I can see the rest of the thing?
Yeah, side.
CDB, CBD.
But that's not what we're
So you're saying
No, the proof that.
this
Yeah, but
is
what
congruent
is
to
it?
this.
Yeah,
Right.
and so
So there you go.
because of that, we know the third side, and then we also know that because since it's the same,
Mr. Hudson.
then also the other two are congruent to the other two, and since it's the same triangle,
Okay, so that's what I.
and it has side. Well, no, it has side congruency.
And and CP.
You said they're congruent to each other, so I made it congruent to each other.
It's well,
I didn't say one's not congruent to two. I just wrote them different.
I know, but it's side congruency.
We haven't written that yet.
Can we write that?
We can write that.
Alright, that's
So triangle ABD and CBD are not only both isosceles, but they are congruent by side. I was waiting to be told what to write down.
Well, yeah,
I
but
didn't want to talk about something.
yeah.
With my hand, and then it took me.
and then CPCDC.
What did I tell you?
So I'm doing the same thing because on the homework I did like CPCPC, but it was similar triangles. For that they were similar.
For this proof to work, there's another reason like CPCTC except for similar triangles. So similar triangles will produce either congruent angles or similar sides that are scaled in the same scale factor.
What's the state?
So you can write it kind of however you want. A lot of these things on the standardized test will be drag reasons into the spaces. It'll be like arrange statements and reasons that work. This is critical to be able to prove what we're actually trying to prove. Because unless we've already said that the base angles are congruent,
Then it could be a different triangle.
they could be different angles. They could be congruent triangles, but like B or D down here and B up here could be different angles, right? But because they're isosceles, we know the base angles are congruent. Which actually, we could have also said that with definition of isosceles, that the base angles are congruent. But at this point, we can say, from side, an isosceles triangle and everything else put together, I'm not going to write it because it's way down there, that angle
Oh, because they're alternate interior too.
ABD here is equal to DBC, or CBD, either way you say it.
It's alternate interior, so the one at D, and then it's the same as the one at D.
Oh, okay.
You don't even really have to use the alternate interior because we've already proven the triangle's congruent.
Yeah.
So that would be using parallel lines. If you use the alternate interior like parallel and a transversal, once we know that the triangles are congruent, and once we know that they're both isosceles, those are both base angles of the isosceles. So there's a couple different ways that you can claim to have gotten to them being congruent to each other, but we
The way
don't.
that we got it, did we need the parallel lines?
I mean, that's a loaded question. Do we always need what we write down in a proof? No. But can it help us piece together what we can do? Yeah.
It's better to write down most of it proof that you don't need the
Yeah.
rest that you need.
So that's essentially like if it's true and if it might be usable, you might as well just write it down. Yeah, you might end up with 3 or 4 statement reasons that don't matter, but if they're true, no one's gonna mark it wrong.
But like this, like saying this is a quadrilateral would not really be helpful.
Yeah, because it's just not purposeful. Now the parallel lines can lead us to other relationships, which is why we would reference them. Anyone else coming to math counts aside from Sophia? Athena, I heard your comment.
Really, Athena?
Yeah, you know.
Free donuts and juice, like fruit, and potentially a giant chocolate bar.
Potentially a giant chocolate.
I'm no good at math.
Really?
Yeah, right.
Nobody?
Come on, Athena.
Yeah.
All right, if we go back to B.
I'm surprised you didn't ask anyone else.
Athena is smart.
No,
one here. She's
Smartest one. I totally participate in all class time. You know, give you guys some answers.
You don't
You're
have to
actually
participate.
participating right now.
We're adding to the conversation.
That's some helpful stuff.
Not the entire thing.
All right,
An auxiliary line?
an auxiliary line.
But I thought you said to never assume things.
We're not.
Assume that angle.
That's given.
Okay.
We're not assuming. They are saying like. So essentially, that should say let angle E be congruent to angle G.
Okay.
But because we're not up to that point in math yet, they just say assume. But yeah, I am pretty critical of that. What's up?
Can I steal a music?
Oh Oh yeah. If there's any left, yeah.
What? If I have two congruent angles, then it's isosceles? Okay.
Thank you. I'm doing my master project first.
To prove that the triangle must be isosceles.
Wait. What's that?
Yeah, what's an auxiliary?
Great question. What do you think?
Oh, a bisecting thing. Like a line.
Like
that
touch
you-
F to the bottom.
Let's
It's
bisect.
any line we add.
Why is it?
Wait, if we're
Sketch
adding.
this on your paper real quick. Doesn't have to be perfect, but
So I've heard like the term like auxiliary chord. Is that?
that yeah. So like auxiliary is like with like auxiliary in marching band, right? The auxiliary is like the color guard, right? The flag people with the guns or batons or whatever you have at the current moment.
I feel like
It's like it's with the band, right? Like an auxiliary chord is like with the sound system. I'm making this up, but if I were to guess why, it's like, you know, there's like a mic chord, right? There's a mic chord and a speaker chord and everything, but then there's like an aux chord is to plug like my iPod in, right? So an aux chord is for something auxiliary to the system. If I'm gonna try to guess an answer, don't laugh at me. I'm trying my hardest here.
Yeah.
Is it a big
We
difference?
don't know,
Oh, wait,
but
but
we
since we're
could
adding the line,
show.
do we not know?
Well, so we do know E congruent to G. What we're doing here is formalizing what isosceles triangles, like what relationship they have. So if we know this, and we dropped this, so when we drop it, we get to determine what it does. I'm going to say it's a right angle.
Yeah, that's what I was saying. Like,
Excuse me. Then, so we would actually, in our proof, say, let FH
Should
be
we-
perpendicular.
should we
Yes.
be writing a proof?
Yes, if you will.
oh wait, we're supposed to be writing a proof for this.
So the given is angle E is equal to angle G. Angle E is congruent to angle G.
Do we use equal as much as like the congruent symbol in like proofs? Like just mainly the congruence?
Congruent is normally being used to reference size of actual like geometric things. Equals is more like algebraic, like 5x equals 15. 5x is not
So-
congruent to 15. They are two objects
so,
that
like,
share the same
You
value.
could say like, just like for instance, like A is congruent to B, it equals like 90 degrees or whatever.
Yeah.
Instead of congruent 90 degrees.
Yeah, but at that point you'd say measure of angle A. You need some sort of measure indicator.
Yeah.
So either the symbol or the M symbol. No. The that. Or the this. Yeah. Which really, the that is actually the this, technically. So, E is congruent to G. Apparently, EHF and GHF are both 90. Where do we go from here?
Right.
Reflexive? Okay.
So
HF is equal
Now, can I use...
should in our proof should we say that we named H the midpoint of?
Oh, right.
Ooh, we don't know that, though.
No, but
We made the line.
But we don't know that it's the midpoint, though.
Why?
yeah.
So, FH is congruent to itself. So we have one side that we can work with here.
But should we at least
We
state?
Wait, what is the reason of why EHF is
Should we state that H?
Wait,
Because we decided.
it's given for angle EHF is congruent to angle GHF, right? Is that given?
That's not given. We made it like we dropped
So
it.
then how?
Because
what
I
was
said
the
so.
reason?
I said
The reason is because I made it.
Yeah, like we just added auxiliary line, just like auxiliary line.
So we should say we add. Wait, I'm confused about how we state that like how we put it in the proof that we made H. What? Like H. What?
Well, I made HH because I wanted H to out.
Let me check what CPM wants you to put as your reason.
Like,
Really, we just say like auxiliary line because we can draw things into it.
Like the statement is like.
All we would have to say is EH, like FH is a line.
Okay.
Like literally, like we created
And
line
then like
FH.
auxiliary line.
Yeah, what problem is this actually?
I don't know.
I forgot how to write H. It was really sad.
Send me a binder attachment.
It didn't attack
I
you.
used my
You attacked
pen.
my
I
binder
used my
and it
pen.
ended up hurting you.
I know.
What
right?
lesson are we on, friends?
7.1.4.
Wait a minute. How did the teacher read it?
Well, just momentarily.
Is it a big difference teaching this 7th graders and then coming and teaching this?
It's weird, right, Mr. Hudson?
Actually, not that many.
So the statement reason they have in here is FM bisects EFG because they just made it happen. So they say FM bisects EFG and point M lies on EG. So we don't know that it is the midpoint. But what we forced it to do was cut the angle in half.
Yeah.
So we took angle F and cut it in half and drew a line.
Okay. Oh, wait. Angle EFM equals angle GFM.
Now-
Definition of angle bisection.
Yeah. So that's the top angle. So actually the route that I took that maybe I shouldn't have, I will be very honest and say I may have made a mistake here. We might not be allowed to say that.
What?
The angles where the auxiliary line meets.
But why?
What we can force is that this equals this, right? But then we could say this because triangle angle sum theorem. Even if we couldn't say it when we dropped the auxiliary line just because we're not 100% sure, quote unquote, like we know it, but because we drew the line mark, what we made happen was we split the angle. This is equal to this, and then triangle angle sum theorem will tell us these are left over. But either way, we've got angle side. So we've got congruent triangles. So from here, we're allowed to say angle side after we've used the reflexive property. They actually don't even. They never even stated that FH is congruent to itself.
So they made a faulty proof.
Well, FM. Sorry, they called it M. Sorry, they did. They don't say reflexive property. They said segment congruent to itself. But reflexive property is a whole lot faster. I think we're out of time.
What? Already? Class is only 30 minutes.
No, I'm a liar. We have class is not only 30 minutes.
I
Is
thought
it?
Friday.
No, that is the wrong schedule up there.
Oh,
Hold on.
right.
No, we're out of here at 10:30. When did you guys get here? Oh, you've been working fast.
You kept the other class later.
I know. Only a couple minutes. I had to finish stuff.
What time is it now?
All right. Does B make sense now that we talked about? The reason is auxiliary line drawn to do whatever. Now we could also say auxiliary line drawn to be perpendicular to EG, if you wanted that to be the thing you care about. But they took the route of caring about the angle bisection up here. If we try C and get rid of this nonsense that I wrote on here, what can congruent triangles tell us about the diagonals of a rectangle? We're going to use the fact that opposite sides are parallel, or rectangles are parallel, which we already proved. You want to prove these diagonals are congruent?
Where?
What's the most efficient way? So, just draw a rectangle on your paper. Where a lot of people get messed up is the efficiency of proofs. We're trying to prove that Ki is equal to Hj. We know that. Actually, well, that's not what they said we know. What they said we know is this.
They're not equal, but they
Excuse
are
me, could I please have Satara Courtney to the office? Satara? The remote office. Thank you.
I always forget to say where I'm like, oh, yeah.
Just think about it. You could bring your amazing attitude to math counts, and it should be a ray of sunshine.
I have better things to do.
Well, so do I, but I'm still gonna beat it.
Was that some? Okay.
Anybody else coming?
No.
Yeah, David is.
I
have a
totally would.
reason.
I'll cheer you guys on in the
David, come on. There's no risk.
It's not the risk, it's that we have stuff to do.
Yeah, that's
Chinese
right.
New Year.
That's a better reason right there.
Yeah.
Actually, I wonder how many is tomorrow Chinese New Year?
Today is Eve, tomorrow, and today there's a big party.
I wonder how many people are going to be impacted by that actually, with us having this competition tomorrow, and there's a robotics thing tomorrow, I think. Or maybe that's not until the February
Yeah,
contest.
that's not so fast. That's all science stuff. I was gonna say.
So wait, what? I want to let you guys talk about this for a second. We have parallel lines. Transversals. So you mean like extend some lines?
Yeah, a bunch of transversals.
There's a lot of opens.
We could do angle IHJ is congruent to angle HKJH.
A lot of vertical angles.
Because of the alternate interior.
I think this has something wrong. IHJ.
Do the pivot.
KHJ. Are you wait what? KJ.
So I think what Sammy's saying is this
Yes.
to this, if I heard you right.
Yeah, because of alternate interior.
Okay.
And
Because
it's
HJs are transversal.
Wait, we can say that angle.
Same on the other side of it.
Can we also say that vertical angles there?
That's not what I meant, but okay.
Oh, you meant like here?
Yeah. You might want to add 2 tick marks.
Hudson, I did not mess up.
I was just gonna come back.
Can we say those are vertical angles?
We can, but do we want to use the smaller triangles or use the bigger
Let's
triangles?
use the bigger triangle since we have those. We don't need to use both.
Oh.
We need to assign the middle of. We could assign the middle of the point. Cause okay.
You can, but you're gonna make things more complicated.
We just need to find a side.
But if you do that, then you have vertical angles. You have angle, angle, angle.
No.
Can we just do our
Oh, you already have 2 angles.
Yeah.
And then we have.
Yeah.
Then
So you know that if you have 2 angles, then the third angle is going to be equal.
Yeah.
And so
Also,
and then the
Wait.
sides are equal.
wait,
We're trying to prove that they're congruent, not similar.
you're right.
So we just can just use that side, one of the transversals, as a reflexive thing, and then prove that they're congruent, like angle side angle.
or we can use HI and KY.
If we prove that the triangles are congruent, then we can prove that the lines are congruent.
So wait. Red, purple, red, green. Red, purple, red, green.
Oh, and they're nice.
So wait, wouldn't red plus purple equal red plus purple? So
Yeah.
couldn't you say angle K equals angle I from like angle addition?
I mean,
Yeah.
they're all 90s.
Then if angle H equals angle J, we actually don't know that they're all 90 yet. Well, unless we just use like definition of rectangle, but we're trying to.
We know that they're similar, right?
So we know red, green combination angle. Red, green combination angle. So we're looking at this triangle and this triangle. Aside from the fact that we have angle relationships, what else could we use here? Of what side? Of like any of them, depending on how I draw it, but right now, how I've drawn it, they share KJ.
Yeah.
So we can write down KJ is equal to KJ because reflexive property, and then we have angle, side, or angle, side, angle, whichever way you want to go. If we go green, side, red, we can then go green, side, red, like they share that side. From the point that we can prove them similar, then we could prove them congruent, or you could just do both at the same time. Then we can use CP, CP, CP. So if you want to see the CPM, like proof
statement reasons.
It's not SPSTP.
Rectangle, parallel, right? So, well, then they prove that the rectangle is a parallelogram, right? Check that out. They prove that the rectangle is a parallelogram. Maybe.
Wait, what would it be like on the 12th one? It said 1 and 2, so like 2.
I'll be super zoomed in. Oh. Check it right here. Do we have to prove that it's a parallelogram? No. But once we say that it's a parallelogram, we can use the stuff we've already proven about parallelograms.
Couldn't they just do that for rectangle though, since they do use the 90 degrees for definition of rectangle?
Have we done a rectangle proof proving that the opposite sides are congruent to each other? Not until now. So we did do parallel proofs or parallelogram proofs. We've done rhombus proofs. We haven't really done rectangle proofs yet. So what we're saying and what we're kind of acting, and maybe I should like intro this differently next year, but like if we are the mathematicians discovering, formalizing, and like dispersing all this info, if we're going to say, we're going to write an article about rectangles and tell everyone everything we know about rectangles, everything we've proven, we'd have to reference back to things we've already proven, right? We can't say the opposite sides of a rectangle are congruent just because they are. We could say the opposite sides of a rectangle are congruent because a rectangle is actually a parallelogram, and we already proved that parallelograms have to have congruent opposite sides. You know what I mean? Then we can say rectangles have opposite congruent sides because remember that proof we did? And that then we can reference. You don't have your hand up, but Sammy does, but it's awkward because you keep starting your sentence.
Next year, since we proved all of this, can we just use it like next year?
Oh yeah.
What
Yeah.
happens if like other people did it and we used it but then
No, so you as a mathematician can reference back to I have proven this. I can show you. Like if somebody came to you and said, I don't believe you, you could say, well, here's a formalized 2-column proof. Eat your heart out, right?
eat your heart out?
It's a phrase. Hey, and this is what 12 would look like. Death. What about trapezoids? This is actually a really, really fun proof that I don't know that I ever would have thought to do this. So ignore what, actually, let me see if I can drag this. Imagine that you just have this trapezoid. Right? We don't have much time left, so I'm not going to make you write down a ton of stuff. If angle H is congruent to angle G, boom, boom. Excuse me. How do the non-parallel side lengths appear to be related? Non-parallel.
Well, they'd intersect at something.
Oh yeah.
Yeah, and that's the thing I don't know that I would have oh yeah, just extend them. Because until I got to Dr. Smith at Otterbein, I would not have immediately said, well, just extend them and then look at the triangle. Right? So if we extend those to their intersection point, it's an isosceles triangle. Well, this is parallel, right, to this. What if this was a right trapezoid? And this turned into...
Oh, I don't like that.
Oh, wait. Crap. This wouldn't be true then. So what sort of trapezoid would we call this then? This is an isosceles trapezoid.
It's a trapezoid.
Seriously, it's an isosceles trapezoid. Just like we have a right trapezoid that when extended would make a right triangle,
wanted to know.
There is an equilateral trapezoid.
There is?
Boom.
That'd be like a square.
Oh. Okay. Well, I mean.
I like when multiple people say it at the same time, and there's like one person in the room who hadn't gotten there yet, and it's like, oh, okay. Because there's actually this research done. We'll come back to this next week. This is really interesting, actually, and you can look it up if you want. There was research done on crossword puzzles that it's this idea of common knowledge, and the thought was that way back years ago when mathematicians and these people were like discovering this stuff and formalizing it, that as soon as somebody figured it out, the humankind had like broken through that window, right, or whatever. And then like I might be like over here in Italy, and you might be over there in Greece, but because I solved it, that knowledge is like out there, and somehow it's easier for you to solve it now, right? Somehow. And I mail you a letter with my solution, but in the time it takes my letter to get to you, you figure it out, and you mail me a letter. And they're like, well, what? Who figured it out first? So there was a study done.
Oh.
Listen, there's a study done with crossword puzzles, where they did a control group, right? People that would do crossword puzzles every day. Then, without knowing it, they gave that group, or like, you know, a part of the group, a day-old crossword puzzle. What do you think happened?
Oh.
They figured out faster.
They solved it more quickly.
How?
That's so weird.
That's not. It's like.
Look it up if
Wait,
you want to.
so
That's
it's
all I
like-
have for you today. I'll leave you on that bombshell.
That human brains have the ability to somehow transfer knowledge to each other.
Here, let me see if I can find it really quick.
No, it's like if I answer. So are you saying that me and Lee were home?
Day-old crossword puzzle study.
Me and Leanne were home, and we were both doing our math homework, and Leanne figured out this question. I would have a higher chance of figuring out that question.
Yeah. Well, not necessarily because
So, I might be making this up because it's from a movie that I've seen, but they talk about it as if it's fact. So I would encourage you to study it.
Stretch
You can take-
There's a movie called Waking Life where a lot of it's in this like weird animated, kind of like colored sort of thing. I will find out if this actually happened. I promise you I will. International Skeptics Forum, SGU.